it looks like nobody's tuning into the live notes, that's perfectly okay. So today we're going to be finishing up chapter 7, talking about algebraically defined vectors and dot products. So basically just what vectors are useful for. And so, yeah, let's go ahead and get to the notes. Okay, so the algebraically defined vectors, we're not really going to fill in a lot of this stuff, just because it's a lot of technical mumbo jumbo. But basically, anytime that we see A and B, A is like X, and B is like Y. Because we're talking about our first component and our second component, which a lot of times we talk about as being X and Y. And so really, these are the important things. So again, remember, magnitude is the length of the vector, and the length is just using the Pythagorean theorem, where it's a squared plus b squared equals c squared. And so then the c squared is really our magnitude, so it's like a squared plus b squared equals our magnitude squared. So then this is where we get our equation for the magnitude. And then for our direction angle, because remember, vectors have both direction and magnitude. And so we have that tangent of theta is equal to b over a, because again, that's tangent is y over x. So tangent of theta is going to be b over a. So if we want to find the magnitude and direction of u, where u is 3, negative 2. So our magnitude is going to be equal to the square root of 3 squared plus negative 2 squared. So then this is going to be the square root of 9 plus 4. So that would be the square root of 13. So that's our magnitude. That's a terrible square root sign, so let me redo that. And then if we want our direction angle, we're going to do tangent of theta equals, this is A and B. So tangent of theta is going to be negative 2 over 3. And so then this is where we use our calculator, and we get that theta equals tangent inverse of negative 2 over 3. And now our calculator is going to give us that this is negative 33.7. But with this vector, so if we have our normal xy plane, this is going to be 3, negative 2, 1, 2, 3, 1, 2. So this is our vector, where it ends at the point 3, negative 2. And so when we're doing this, we want this direction angle. So this is the theta that we want. So what we need to do is add 360 to what our calculator gives us if it's negative. And so then tangent of is, so then theta is equal to 326.3 degrees. And so you always want to be sure which quadrant you're in, because here, because of the 3, negative 2, we know that we are in the fourth quadrant, which 326.3 is in the fourth quadrant. Okay, so then if we're talking about the horizontal and vertical components, so this is, again, is really talking about where A is like X, B is like Y, where this is the horizontal and this is the vertical. And so again, thinking about how we write a vector, we're going to write it with the horizontal and vertical because it's the X and the Y. And so if we're given the magnitude and the direction of a vector, we want to write this as the magnitude is 25 times cosine of 42.7. So this is going to be our A. And so then we type that into our calculator and we get that A is 18.4. And then B is going to be our magnitude times sine of 42.7. Again, you want to be sure that your calculator is in degree mode for this. And so then we get that B is equal to 17. So then we write our vector as sort of these, they're not quite the less than or greater than symbols, but they're sort of just a V'd bracket. So it would be 18.4, 17. So this is our horizontal and vertical components, or just our vector. So then, for example, 3, we have 3 different ones where we want to write the vector in the form A, B. So we want to write it with our horizontal and vertical components. So the magnitude is going to be 5 with a direction of 60. And so with this, A would be 5 times cosine of 60. B would be 5 times sine of 60. Now, we know what the sine and cosine of 60 is without using our calculator, so we're going to use our unit circle to find the exact values for cosine of 60 and sine of 60. So then A is 5 times 1/2, or 5/2. And then B would be 5 times √3/2. And so we just write that as 5 √3/2. So then our vector would be 5/2, and then 5 √3/2. Okay, so then for the next one, we're going to do the exact same thing. So A is going to be 2 cosine of 180. B is 2 sine of 180. And so we know that cosine of 180 is -1. So A is -2. Sine of 180 is 0. So our B, or our vertical component, would be 0. So then this would be the vector -2, 0. And then our magnitude, and then for W, we have that our horizontal component would be 6 cosine of 280. Our vertical component would be 6 sine of 280. Now, do we know what the sine or cosine of 280 is from our unit circle? No. So we're going to use our calculator, and then we get that this is 1.04 for our horizontal and negative 5.9 for our vertical. So that is how we write a vector when we're given the magnitude and the direction. Now we are going to talk about what some algebra that we can do with vectors. And so basically what this is saying is that if we are adding vectors, so if we are adding vectors, we're going to add the x's and add the y's. So that's what we're doing here. And so if we have -2, 1 as u and 4, 3 as v, then u plus v is going to be -2 plus 4, comma 1 plus 3. And so then this would be, here, hold on, let me write this up. So we're taking -2, 1 plus 4, 3. So then we get -2 plus 4, comma 1 plus 3. And so then this would give us 2, 4 as our vector u plus v. Then if we have where it's multiplied, then it's sort of just like distribution. We're distributing the number into the vector. So this is going to be -2 times the vector -2, 1. And so then this would just be the vector 4, -2. So then if we're combining these, this is going to be 3 times the vector -2, 1 minus 2 times the vector 4, 3. And so then I'm going to distribute the 3, so this becomes -6, 3, and then minus 8, 6. So then this would be -6 minus 8, comma 3 minus 6. So then we get this vector -14, -3. Okay, and so then for the ij form of vector, basically our i's are associated with a or x, and then our j is associated with b or y. So our I is always going to be the horizontal component, and the j is always going to be the vertical component. And so we can write a vector in this way. And then for the dot product, I'm not going to worry about the definition, but what this means is that you're multiplying the components and then adding them. So if you have a dot product, you're taking two vectors and sort of multiplying them together, but then you get a scalar. So you get just a regular number. Dot products give you a number, not another vector. So if we want to take the dot product of these two vectors, what is going to happen is we're going to have 2 times 4 plus 3 times -1. And so then this would give us 8 plus -3. So we get 5 as our dot product. And so then with this one, it would be 6 times -2 plus 4 times 3. So then this would be -12 plus 12, which would be 0. Okay, so then these are just some properties of the dot product. You really don't have to worry about that a whole lot. You're mostly going to just be focusing on just the regular dot product, like in example 5. But then the geometric interpretation of the dot product. So basically, what is useful with the dot product is that it helps you to find the angle between two vectors. And so in order to do that, we use this formula that cosine of theta is equal to the dot product of the two vectors divided by their magnitudes added together. And so again, remember that the magnitude is basically just the Pythagorean theorem. So let's sort of look at what is happening here. So for you, this is here, where this is 3, our vertical component is 4. So we can draw our triangle like we always do. And so we know that this magnitude is going to be 5 because that's the length of this. Then for V, we're also in quadrant 1, where this is 2, then our vertical component is 1. So then we do the magnitude of V is going to be the square root of 2 squared plus 1 squared. So this would be the square root of 5. So we have our magnitude of V, magnitude of U. Now we just need the dot product. And so this would be 3 times 2 plus 4 times 1. So 6 plus 4, 10. So this is U dot V. So then we have cosine of theta equals U dot V divided by the magnitude of U times the magnitude of V. So then we get that this is 10 divided by 5 times the square root of 5, which then this can be simplified to just 2 over root 5. And so remember, we're actually looking for theta. And so then we take cosine inverse of 2 over root 5. And so then we get that theta is equal to 26.6 degrees. Okay, so that, I want you guys to try this one. And so I will put the answers in the OneNote document after I stop recording this. And then Miss Humphrey's notes are also in the OneNote document. She just forgot to record her notes. So you can look at mine or hers. They're basically the same. She might just have better handwriting. So if you want to look at hers for the handwriting, that is perfectly okay. And yeah, that's all I have for you. So have a great day.